This piece of research was more about finding out, like, it's an investigation about the plastic waste in Aalborg municipality, like what can we learn from the bottom of a waste bin. My name is Edward Vingwe. I'm a PhD fellow at Aalborg Uni. The agenda pretty much is going to be about providing the context of what initiated this piece of research and the purpose, and I'll present the methodology and the results, and obviously the conclusion and the future perspectives. I'll also present some of the reflections that I learned from this experiment. The context of it is that Aalborg municipality introduced like a new policy for household waste sorting between 2016 and 2017, and the policy basically enabled and enhanced the source sorting for household waste from everyday life. And the sorting categories is that we separate glass, we put it in a specific compartment in, as you can see on the picture. So we're separating glass, and we put metal and plastic together, and paper and cardboard together, and the residual waste, which is pretty much like the waste from food and etc., food waste and etc. And also, like, all the residual waste is mostly, it goes mostly for incineration, and the rest of it, like the glass and the plastic and the metal and cardboard, is intended for recycling at material level, as you can see on in the pictures. The purpose of this study was really like to find out, even though the source separating, when I say the source separating, before in Aalborg, people had to go either to recycling stations to drop off, for example, glass and the metals and etc., etc. But now citizens in Aalborg, they have all this infrastructure, as you can see in the previous slide, that they can simply have a small system within their housing where they separate all these materials, and they can go down and drop off the materials in the infrastructure as shown in the slide before. Different from that is that the single housing, the single family housing, they have their own private waste containers, which resembles pretty much the same system as you can see in the previous slide. But nonetheless, the purpose for this study was, after introducing this new policy in Aalborg, the curiosity was more about finding out how much plastic waste you can still find discarded in the residual waste fraction in the households. Obviously the second purpose was more about finding out whether the plastic that is discarded in the residual waste fraction could be recycled economically and environmentally feasible. The other point was more about like finding out the opportunities and challenges associated with plastic waste that is thrown into the residual waste fraction. The methodology, we call it, the Department of Planning and Development at Aalborg Uni, we collaborated with Noah, which owns like the most modern sorting waste sorting facility, which is based on it combines both, it sorts the waste both based on density and based on magnetic, and it also uses like the infrared scans. The facility is privately privately owned, but it's also owned by the municipality, but by the region, by the public sector within the region. And we also collaborated with Aalborg Municipality Waste Department, which is Aalborg Renovation, and we collaborated with those two organizations. And the sampling was really based on a random sampling. And what we did was mostly like looking at the housing system, the most predominant housing system in Aalborg, which is mostly composed of single-family housing and multi-family housing, which are mostly apartments, and the service sector, which is predominantly restaurants and hotels and et cetera, et cetera. And the samples that we collected from the single family housing, it was about 12,000 kilograms, and about also 12,000 kilograms from multi-housing, and about 10,000 from the service sector. When we collected those samples, what we did was more about opening all the bags that contained the residual waste and find out what are the most representative plastic products per sample. When I say representative products, I mean, like if you have like 4 Coca-Cola bottles that resembles each other, then you would pick one. So that pretty much what it means when I speak about the representative products, plastic products. And after that, we weighted the products in situ, and thereafter we washed them and dried them and weighted them again to get this dry weight. The idea behind that was more about finding out how contaminated the plastic products from these samples were. And then after that, we took each product and find out which components were disassemblable, and we separated that, and those became like our articles or components per product. And we collected those and labeled them per product for lab analysis. And I used this attenuated reflection Fourier transform infrared spectroscopy, the ATR, FTIR, to determine the composition of each of the articles per product. I think what was more interesting was obviously about finding out, when we collected the products in situ, how much cleaning would it take? For example, like the weight in the beginning and the weight after washing and drying, the difference of it was more about giving some insights on what it would take, for example, to clean some of these materials for recycling. And as you can see on the results, you can see that from the single family housing, the weight dropped after washing and drying. It dropped up to almost 33% from the single family housing, and from the multi-family housing, the weight dropped up to 40 or 41%, and from the service sector, which is mostly composed of restaurants and hotels and etc., it dropped up to 50%, which means that the service sector, the materials, the waste from the plastic waste from the service sector was dirtier compared to the single family housing. Then obviously what was more interesting when it comes to upcycling of the plastic waste that we could find in the residual waste fraction in Aalborg was that we distributed them per product that was composed of homogeneous polymers and products which were composed of mixed polymers and products that were composed of multi-layered polymers. What we can see on this slide right now is that the difference is not that much. The service sector, it composed the articles that the products that we collected from the service sector had more products which were composed of homogeneous polymers compared to, for example, the multi-family houses, and but the difference is not really that much. And at the same time, when you look at the multi-layered polymers, when I say multi-layered polymers, it's like the same kind of article. You analyze it from the inner side layer and from the outside layer, and it's composing of either two different polymer types. So what we see in this slide right now is it simply shows that the difference is not that higher when you look at the products which were composed of homogeneous polymers. When you look at both the single family houses and the multi-family houses in the service sector, but obviously the service sector, our analysis shows that there were more products that were composed of homogeneous polymers in the service sector, which also highlights the multi-layered polymers. You'll find also many multi-layered polymer products within the service sector. As for the mixed polymer products, still the service sector constitutes quite a higher number of products that are made out of mixed polymers. The next step was more about to find out what are the most predominant polymers that you can find in the products that we collected. We found out that in the service sector, the polyethylene was higher in the pretty much in all the single family housing. I mean, was higher in the service sector, but the difference when you look at the single family houses and the multi-family houses, the difference is really smaller. And then we had this polypropylene, which was like the most significant polymer from the products that we analyzed. Then PET was more predominant within the service sector, as you can see, as in the single family houses and multi-family houses was pretty much similar. When you look at the polymethylpentane, was pretty much the same results that we get in all the samples that we collected. As for polystyrene, there were some differences. Most of it, I think, as you can see, the service sector uses more polystyrene compared to the multi-family houses and the single family houses. And when I wrote like others, it was more copolymers and which was like more diverse. The conclusion that we could make out of this piece of research was that the residents of Aalborg municipality responded quite positively to the new policy. However, there were considerable amounts of plastic waste we could still find in the residual waste fraction. The differences in the volumes of the plastic waste when you compare between the single family and the multi-family residences was quite smaller than expected. There was some assumption that there would be a greater difference due to convenience, that people who live in apartments who share, who have this collective sorting system, they have to have kind of an independent sorting system where, first of all, you sort it in your apartment, put it all together, then you go downstairs and drop it off at this the pictures that I showed in earlier on. And there's been like all these assumptions that most of the plastic waste will be discarded in the residual waste in the apartments compared to the single family houses, because the single family houses, they have their own private containers, waste containers, where they could just, walk outside and just drop them out there, which actually questions the hypothesis, which was proven quite wrong. And on the other hand, the difference between the residential and service sector waste streams was quite considerable. But overall, regarding the samples that we collected, there were pretty much several factors that we found out that could affect the recyclability of most of the plastic waste that is discarded in the residual waste fraction. And those three was more about the product design strategies, where there's so much mix of use of polymers, mixed polymers, polymer types, which obviously would take a lot of energy and a lot of resources to separate those materials. And the multi-layered materials, obviously, if you have to recycle them, then you would end up downcycling. The question is whether downcycling is bad or not, but the target so far is more about upcycling, and also it's more about the preferences of the reprocessing companies. The reprocessing companies, they have specific kind of preferences which are considering both mostly the economy aspect of it, and the environment is more common. A lot of companies are thinking so much about reprocessing companies are thinking so much about, like, okay, can we recycle, can we reprocess specific kind of plastic waste economically viable and also environmentally viable, which are some metrics that they have to balance, but at the end of it, they have to make a business case out of this. The other issue was mostly associated with the contamination from food waste. Like, the residual plastic waste is where, when you find the plastic waste in the residual waste fraction, is mostly combined with food waste. And that itself, it would mean that you would need to clean, even if you find some high quality plastic waste that can be recyclable, then you have to use quite a substantial amount of energy and water to clean those plastic waste products for it to be recycled financially and economically, economically and environmentally feasible. And the other issue when I talk about contamination from food waste is that some of the products, for example, when you look at the ketchup bottle, not all the ketchup gets out of the ketchup bottle, even if it's empty. And that was also another issue. So it's not only from the food waste contamination, but it's just the way we design the products that we can't completely empty those products. And in that case, it's another case that I think would be interesting to look into the product design of some of these plastic products. And the final issue was more related to the quality or how high quality were some of the polymers used in the products. You'll find a lot of firms in packaging materials which has really low value, economical value, which many reprocessing companies would not be interested to take in because basically it's difficult to recycle them. My reflections throughout the experiment was that the use of homogeneous polymer types in short-lived plastic products would play quite a big role into improving the upcycling of plastic waste. And we also need an improved product design when it comes to how to empty and clean some of these plastic products. And obviously there's going to be a need of change of practice when you look to the end user in respect to emptying and cleaning and sorting of these plastic products. But when you consider it, if I have to clean, for example, a ketchup bottle where I have to use quite a substantial amount of water in my household, obviously, the question would be like, how much water can I use that it becomes substantially environmental friendly? So there is also a balance right there. When you look at, I think there's the other reflection that I started like thinking about was more the improved technology at every stage could play an important role as to improving the upcycling of some of these conventional plastics, plastic waste that we use on an everyday basis. And when it comes to innovation, I think it will be quite important to consider some of the alternative materials such as bio and biodegradable plastic and most important, I think the use of reusable plastic products should be somehow resurrected, because the more you can reuse a certain product, like when you go out shopping, you can reuse a certain bag for a number of times. I think that could be also considered. And for example, the lunch boxes that are made from plastic, you can use them over and over and over again. And that could be also another kind of aspect when it comes to considering the sustainable or the plastic in the circular economy, and that is connected to the change of lifestyles, and obviously the better coordination all along the value chain. When I say that, I'm considering that the producers need to consider how at the end of use of this kind of product, how can it be managed sustainably, and that involves both producers, consumers, and also we need to improve our collection systems and in consideration of what reprocessing companies are capable of considering. do exist right now. As for the future study, I think it would be quite interesting to see, like, to perform the kind of experiment in a couple of years to see whether there is a change from when I did this experiment to the current situation. I think it will be quite interesting to see the changes. Thank you.